Hi. Hello, everybody. Hello. Very good evening. How are you all? Uన్నారు అందరికి. Hi, Maitri. Very good evening. Hi. Hey, am I audible? ఒక్కసారి చెప్పండి రా. Everything clear? Mic and audio. Okay. So, shall we start, all of you? If you don't have any problem, I think we can start, right? Me? Yes. Okay. So, let us start this session, Ra. అందరికి. Just tell me if I'm audible or not. దాని తర్వాత we will just start it. Okay. చెప్పండి. Visible, audible, all of you? Hey, am I audible? Am I audible and visible? Okay. Oh, thank you so much, Gonat. So I think we can start, right? No problem in starting this. Hi, Spandana. Hi, Nandini. Hi. I don't have birthday, Nandini. I have a birthday. I don't have it. Yeah. Okay. Thank you so much, Gonat, thank you so much. And I all was a little hectic day for me. Okay. Mm-hmm. So hi. Okay, Nandini, let us see. Okay, if possible, if time permits us, then we will definitely do one shot for all of them. Good evening. Hey, like చేసుకోండి రా, వీడియోని లైక్ చేసుకోండి ఒక్కసారి. 13 people are only watching రే. What happened to the attendance రే? Yes, Yashwant Kumar. Hello. Good evening. Hi, good evening. Okay. Okay. చెప్పండి అందరికి. How is everything going, Ray? How is the day going? Yeah, happy Christmas, sir. Yeah, Nandini, how the day is going, Nandini? Yes. Thank you so much, Andariki. Thank you so much. How the day is going on? Hectic, chala hectic kada? Sir, it should be the holiday na, sir. Why are you taking the classes? Good evening, Joshna. Very good evening. Hi, Chikiri. Uh, I don't know the lyrics, otherwise I would have sing that song for you, know. Know the lyrics, Ray. Cheppandi. Good. Mysterious, good. So I think we are in a position to start, Ray. Hey, in this session, andariki chuskondi. In this session, we'll just be talking about circular motion. Ante kada? Kinematics 2D lo. Yeah. Only we will be talking about what, Ray? We will be talking about circular motion only, na. major topic will be circular motion only. So all the terminologies and all the concepts, questions including PYQs discuss cheddam. Okay. Aim song Spandana, వేరే song అంటే ఏంటి? Hi Nishika, hi. సో స్టార్ట్ చేద్దాం అందరికి, చూసుకోండి రా, చూసుకోండి. ఓకే, సో సర్క్యులర్ మోషన్ రే. ఏ వాట్ ఈస్ సర్కిల్ సార్? సార్ సర్కిల్ ఈజ్ అ కలెక్షన్ ఆఫ్ ఫిక్స్ పాయింట్స్ ఫ్రమ్ అ గివెన్ పాయింట్, అంతే కదా? దట్ ఈస్ నోన్ యాజ్ ద సెంటర్ ఆఫ్ ద సర్కిల్. ఓకే 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 చలో, possible, we'll see. Okay, we'll see. Hey, what are you typing, Ray? Fine, I'm fine. Yes, it should be holiday today. It's not there. So ఏం చేయాలా మరి if it's not holiday today రా? Gonut, I have seen you for the first time. You're telling that your physics has improved because of me. What's your name, Gonut? What's your name? Parenti. They're, very old. Yeah, Gonut, I'm asking to you only, Gonut. No, who are you? Oh, I see. So both are single, right? Why is why is there the condition of today only? Huh? Hey, chuddam ra. Let it be. Hey, let it be. Lalita, I'm sorry, Lalita. I haven't recognized you. No, not Bollywood. Na. How Bollywood? Re? How Bollywood? Huh? They're not Bollywood. Okay. Even if they are marrying, what with us? Are they calling us in their marriage? They're not calling us, right? They're not calling us in their marriage, right? Oh. Gossips and the channel, this video gets recorded, right? I'll not get my salary, I'll be fired if I do gossips. Gossips just throw me out of the company. ఓకే, స్టార్ట్ చేద్దాం అందరికి. చూసుకోండిరా, చూసుకోండి. సో సర్క్యులర్ మోషన్ అంటే ఏంటిరా? సో సర్క్యులర్ మోషన్ అంటే, లెట్ us imagine this is the center of the circle. Hey, can you see this dot? Yes. So yeah, I know. So if you know this center, hey, then you can take a particle and tell that particle to move around in a circular manner. Okay, so this is known as my circular motion. Ante kada? Oh, okay, Gonat, thank you so much, Gonat, thank you so much. Okay. Yes, let us see. Chalo, చూసుకోండి రే. Hey, so this is the circular motion, ante kada? So there will be a mass, some mass m here, and it is moving in a circular motion. Where the letters are going, okay, so mass m is there. Mass m is there. Okay, yeah, let's be serious. Okay, చాలా gossips రా. Chalo, so now let us start. సో ఒక కండిషన్ ఉంటుందిరా సర్క్యులర్ మోషన్ చేయడానికి. వాట్ ఇస్ ద కండిషన్ అంటే సార్ if you just want to make a circular motion happen, then let us say this mass is m, hey, and I want this mass to move in a circle. There is one very important condition ra. What is the condition ante there must be a force that is always directed towards the center. Ante kada what I am telling re, for any circular motion to happen, there must be a force directed towards the center of the circle. Are you understanding? Condition ante for any circular motion, చూసుకోండి రా, for any circular motion a force is required. Which force re? Which force? The force must always be directed towards the center. Ante kada, force must be directed towards the center. Yes, good. Ritik Verma, good. You can also say that, but hi Isha, hi. Okay. So, but what the condition is, every time you want the force to be directed towards the center of the circle. Ante kada? Yes. So that means if this is my center ray, particle is here, e position low, force must be like here, and the second condition is that the particle must be in a speed ray. Hey, in a speed. Okay. So what does it mean, ray? What does it mean? So if this is mass m ray, if this is mass m, ee mass m daggara two conditions unnai. What are the first condition? It is always being acted upon a force that is directed towards the center. First condition, ante kada. The second condition is it must have a speed ra, ante. So speed and a force all the times. So if it is coming here ray, cheppandi, force should be towards the center, speed should be radially or in a tangential direction, ante kada. So this way at all the points it performs a circular motion. Ante enti ra? Okay. Yeah, Nandini, I heard it. I read it. Okay. So, okay. So when the particle is coming here, the centripetal force must be towards the center and the speed must be in a tangential direction. Chuskondi ra. At each and every point, without a force towards the center, circular motion is not possible. Ante kada? Without a force towards the center, circular motion is not possible. Ide center ni act chestina force ki I will call it centripetal force ra. Are you understanding? Centripetal ante it just a name ra, oka degree, oka post ante enti sir? MLA is a post, MP is a post, Prime Minister, Chief Minister, they are the posts kada. Yes. So the person sitting on that chair of MLA is known as MLA kada. So persons may be different, but post is the same. Similarly, the force towards the center is a post centripetal force. Now different forces can act as centripetal force. Ante kada? Okay. Different forces could act as centripetal forces. For example, you can say, sir, tension force, gravitation force, electrostatic force, normal force, all are the types of forces ra. All are the types of forces. Hi Spandana, hi. You are telling something? Okay. So all are the types of forces, but they must be acting towards the center of the circle only. Then and only then we will call it as centripetal force. Understanding? What is centripetal force re? Centripetal force ki definition ante, number 1, the force that acts always towards the center. Hey, on which ray? On what the force is acting ray? On the particle which is moving in a circular motion, not electromagnetic. Yeah, it could be, good, very good. It could be electromagnetic force also. So you can simply say, sir, number 2, without centripetal force, you understand it's a very basic topic, okay? Without a centripetal force, circular motion is impossible, okay? So without a centripetal force, circular motion is impossible. ఏదైనా తీసుకోండి, ఏదైనా చేయండి, circular motion is impossible without a centripetal force. అంటే whenever an object is moving round and round and round, you always imagine that there is a force acting on that particle that is acting always towards the center. అంతే కదా? Yes. Centrifugal and centripetal, nothing difference. Basically you understand centrifugal ante it acts, how should I say? I'll take with an example, okay? I'll tell you with an example. Chuskondi. So there is this string, okay? String. There is this string, okay? So it is my string, and in string ni I have connected a ball of mass m. Chuskondi andariki. So this is the ball of mass m, and now I am rotating it something like this. So ante the ball will move in a circular motion kada? Yes. In this scenario deetlo, yes, F and V must be perpendicular. Go nut. Very good. Okay, you can simply say the string is pulling the bob in the internal part, ante kada? Internal part re. So basically the force that is acting towards the center is known as centripetal force. Hey, what will happen, right? Did I say centripetal or centrifugal? Yes. Okay. So the force that is acting towards the center is known as centripetal force. If I am cutting this string, chuskondi, the ball is rotating and immediately I am cutting this string. This ball will fall away kada? Or the best example is, it is my moving disc. Andariki observe cheskondi. On this disc I am putting a block of mass m. If it is rotating too fast, this m will fall out of the disc. Ante kada? The force that is acting away from the center is known as centrifugal force, and this is centripetal. Same significance. Value is same, only the direction is opposite. Are you understanding? Okay? Are you understanding? Okay. So only the direction is different. Okay, so this is known as centrifugal force. Value of both the forces is almost the same. The only difference is that here we don't have anything to balance. So the object is not performing circular motion. Are you understanding? The object is getting thrown out. Centrifugal force. The object is being pulled inside. Centripetal force. Towards the center, centripetal. Away from the center, centrifugal. Understanding? Yes. Good. Next. Okay. So let us take some examples. Hey, I told you that whenever a circular motion is happening, point number 1, there must be a force acting towards the center. Ante kada? That force is known as centripetal force. And different forces can act as centripetal force. Andariki chuskondira. So if it is gravitation, it could be acting as a centripetal force. Chuskondi. Centripetal ante oka position ra. Okay, centripetal force is a position like MLA, MP. Different people sit on it kada. Similarly, different forces act as a centripetal force. I hope you are understanding. Okay. So sir, if gravitation is acting as centripetal force, chuskondi. Let us say ide na first mass capital M ra. Hey, chuskondi re. Hey, chuskondi, capital M. Before this, you observe, okay, condition I am telling you. If this is my mass M ray, hey, revolving in a circle of radius R ray, radius is R, and speed is V ray, speed is V. Vere speeds ni, vere centripetal force value ustundi. Okay, no. We are telling that basically, sir, the value of this centripetal force is dependent on three things. Okay, the value of the centripetal force is dependent on three things. Number one, centripetal force is directly proportional to the mass of the object. Ante entira, take heavier objects, పెద్ద objects తీసి, the force required to keep in a circle ante centripetal force, it also increases ra. You increase the mass. Yes, Gonu. Yes, that's what I'm telling to you. Gravitation is a force which is acting as centripetal force. Similarly, tension could be the force that could act as centripetal force. Are you understanding? Okay, so centripetal force is directly dependent on mass. Ante entira, chuskondi. Basic simple rule. What is the rule, sir? If this particle wants to move in a circle, the nature will tell this particle that for a given mass, you can have only a given speed rate. Are you understanding? For example, centripetal force is directly proportional to speed square, and sir, centripetal force is inversely proportional to radius of the circular motion. Ante. So these are the three conditions for a circular motion. Are you understanding? So what happens if you combine all three, you can simply say centripetal force is equals to mv square by r. Ante enti, sir? Ante enti? Chuskondira. For example, okay, I'll add here. Okay, so let us say there is this mass of 10 kg. Hey, there is this mass of 10 kg rotating in a circle of radius 2 meters, 2 meters, and the speed is v is equals to 10 meter per second. Are you understanding? So, sir, if you are trying to move with the help of a string, or with the help of a gravitation attraction, or with the help of electrostatic attraction, imagine this is my string, ante kada? So this is my string. So what's happening, right? The ball wants to go out, but the string is keeping this ball in motion, ante kada? In place. So this string is keeping this ball in the place, ante in motion. Are you understanding? This string will keep the block or ball in place. Ante this string will have to apply some force kada? How much force, re? How much force? Centripetal force. What's the formula, re? What's the formula? Centripetal force is equals to mv square by r. Ante entira, if this 10 kg block wants to move in a circle, if this 10 kg block has to move in a circle, ante it must follow this condition, re. What condition? Substitute the values, ra. Mass is 10, so velocity square ante 10 square divided by radius is 2 ante kada? So it is equals to 500 Newton. Are you understanding? So what, sir? What does it mean? If this mass has to move in a circle, ray, then there must be a force of 500 Newton. If the force is less, the particle will move away. It will not perform circular motion. Similarly, if the force is more, again the particle will not be able to perform circular motion. Are you understanding? So a particle kosam, the required amount of force is very precise and very calculated. So very mass తీసి we get different values of the forces also. Understanding? So for a 10 kg block to move in a radius of 2 meter with 10 meter per second speed rate, it must have 500 Newton of force always directed towards the center of the circle. Are you understanding? Are you understanding? Which photo, Spandana? Okay. Good. Gunnar, good. Very good. Lalita, good. Are you understanding? So, sir, different forces could act as gravitational force. Ante entira, if my gravitational force is acting as a centripetal force, okay, if my gravitational force is acting as, good evening Bhanu, good evening. If my gravitational force is acting as centripetal force, ra, chuskondi. So this is the particle, ide na earth re. Hey, this is my earth and this is my sun. Understanding? Mass capital M, ekkada vachi mass small m ra. Let us say the radius is r. Chuskondi andariki. Ante enti ra? It must also have the same condition, ada? Okay, it must also have the same condition to move. What condition, re? It must have some force. How much force, re? How much force? Centripetal force. Cheppandi value, re? mv square by r. So this must be the force that is acting on earth at all the times to be in a circular motion. Okay, to be in a circular motion. Sir, if this is the force required, if this is the value, this is the amount, this is the magnitude of force required for this earth to be in a circular motion, who is providing this much force? Are you understanding? Okay, okay. Who is providing this centripetal force? Ante this gravitational force is providing that force. Are you understanding? Ante what is gravitational force between two objects? Ga times of m1 times of m2 divided by r square. Ante kada gm1 m2 by r square. This gravitational force should be equal to that value. That value is a required value. That value is a required value for the earth to be in a circle. If the value is not equal to this, earth will not move in a circle. Ante kada? So this is the required value. Who is providing this, sir? Gravity between the two objects. So gravity is this much, it should be equal to that value. So small m into v square by r. So ikkada nunchi ఏదైనా క్యాన్సిల్ చేయొచ్చు, క్యాన్సిల్ చేసుకోండి. r gone, రే. Okay, so you can simply say, sir, g into m divided by r is equals to v square. అంటే ఏంటిరా? అంటే v is equals to root of g into capital M by r. చూసుకోండి, capital M అంటే mass of the sun. సెంట్రల్ ఆబ్జెక్ట్స్ కి మాస్ తీసుకోండి. ఓకే, hope you are understanding. Okay, so this is the speed, ray. Ante enti, sir, if this particle wants to be in a circular motion, its speed must be equal to this, ra. If the speed is less, takkuva aithe it shrinks, ante it collapses into the orbital planet only. If the speed is more, ekkuva aithe it will leave the orbit, it will not perform circular motion. Are you understanding? Good. Example number 2, ra. String. చూసుకోండి అందరికి. స్ట్రింగ్ లో ఏం ఫోర్స్ ఉన్నాయిరా? ఇఫ్ దేర్ ఆర్ సమ్ డ్రాపర్స్, ఇఫ్ class 11 students are there, you might feel a little difficult to understand all this, but for droppers it is very easy. Cheppandi. So string has a tension force. Andariki string has a tension force kada? Yes. So sir, na daggara oka string unte I am attaching a mass m to this string, ray, and I am actually moving this mass in a circular motion. Circular motion ante, let us say, okay. So what you can imagine is, let us say the speed is v, ra. Speed is v, radius is r, ante kada. So ante for this mass to move in a circle, how much force is required, right? Required force cheppandi. For this mass to be in a circular motion, to be in that state of motion only, some force is required. If the force is not equal to that force, it will not move in a circle. Are you understanding? So some force is required. How much force, re? m v square divided by r. R ante radius of the circle, v ante velocity of the object, m ante its mass. Ante kada? That force is a required force for this, and ide force ni we are calling at as the centripetal force kada? All the times this amount of force should be acting on the particle, and the direction of that force must be always towards the center. Chuskondi, ide force ni I am calling it a centripetal force. This is the required force, required value, the required amount of force. Good, very good, Samir, very good. So this is the required amount of force. Sir, who is providing that force now? చూసుకోండి, స్ట్రింగ్ కదా. సో స్ట్రింగ్ లో ఒక టెన్షన్ ఫోర్స్ ఉన్నది. సో యూ కెన్ సింప్లీ సే, సార్, టెన్షన్ ఫోర్స్ మస్ట్ బి ఈక్వల్ టు దట్ వాల్యూ, సార్. Then and only then it will move in a circle. When, sir, when the value of tension force, why tension? Because tension is the only force keeping this block inside the circular motion. Ante kada, always acting towards the center. Okay. Hi Vivek. Hi. Any doubts? No doubts. Chalo, good. So that I can simply say, sir, tension is equals to mv square by r. Ante. So if you have a very good string, can support higher speeds also. But if you have a very light string, thin string, its tension cannot provide the necessary amount of centripetal force kada. Okay, that is the reason. Yes, so that is the reason why the tension force is active. Normal force gurinchi cheptunna chuskondi. What is normal force and how does it act as a centripetal force ra? Cheppandi andariki. How does a normal force act as a centripetal force? I don't have something to do the experiment. Okay, I don't have something to do the experiment. Kani, you can imagine. Okay, you can imagine one thing. I'll tell you. I will tell you. Getting anything? Really, I'm not getting anything. I will tell you. You imagine, right? Oh, Spandana, how should I give you? I don't know your address, right? I'll send you on your address. Yes, not all directions, always directed towards the center. Okay, always directed towards the center, something like this. Centripetal force is always directed towards the center. Normal reaction gurinchi chuskondi. Let us say I have a stone. Okay, I have a small stone. Okay, small stone తీసుకోండి. Okay. Take a small stone and also take one more glass. Glass. Okay, oka glass ni తీసి you put the glass on the stone. Are you understanding? Reverse. Hey, upside down. So you take a stone and you put it upside down. Ante kada. And suddenly what do you do is you start rotating that glass ray fast, something like this, fast. So what happens is this stone now moves along the walls of this glass. And if you are moving it very high speed, the stone will attach to the walls only. Okay, it will not fall down, ray. It will not fall down. Ante kada? So it will not fall down. Chuskondi. Here, ray. Normal force works in the same principle. Similarly, hey, have you seen that mouth ka kuwa re? Circus lo, there is yes. Yeah. But you have to understand, right? You have to understand the forces that are acting. Normal force should be equals to mv square by r. Ante enti ra? Chuskondi. So if this is my well of death ra, mouth ka kuwa, they also call it something like this. Okay, what they do is they take bikes re, and they take the bikes and move along a circular motion along the walls only. So how is it even possible, ra? How is it possible? Normal force only, ra. Normal force. So always remember, if the mass is m ray and if the object is moving with a speed v ra, hey, speed is v, mass is m, radius is r ray. Chuskondi. Again, to move in circular motion, what force is required? Sir, okay, what force is required? Force required is equals to mv square by r, ante kada? Yes. So this is the required force. Who is providing it? The walls. Walls ante normal reaction. So in that scenario, normal force should also be equals to mv square by r. Ante r is the radius, v is the speed with which the object is moving. Okay. Hey, Maitri, it's 7, right? You're talking about lunch now. Huh? Okay. Electrostatic force, ra. Again, it's a very good example actually. If there are droppers in this class, okay, if there are droppers in this class, yes, if there are droppers in this class, they'll understand it. Okay, imagine, hey, na daggara 2 charges untundira, plus q1, ikkada minus q. Ante kada? You give some speed to it, Ray. You give some speed. Ante kada? You have already attraction. Now only thing that you will do is give some speed, v speed. Ante. And let us say the distance between these two is r. Automatically it will move in a circular motion, ra. Okkasari ee particle ni speed iste, it will automatically perform a circular motion. Ante kada? Okay. Sir, if it has a mass m, hey, mass also matters, Ray. If it has a mass m, how much force is required? How much force is required, ra? Yeah, Maitri, done. Okay. So how much force is required? Required force is equals to mv square by r ante kada. This is the required force. Required. Then who is providing that force? Who is providing that much of required force? Ide electrostatic force. What is the formula for electrostatic force? Sir? K q1 q2 divided by r square must be equals to m into v square by r ante kada. M ante mass of the object that is performing circular motion. Chuskondi. R gone re. Ekkad nunchi what you can get is, sir, v square is equals to k q1 q2 divided by m into r, and thus speed is equals to root of k q1 q2 divided by m into r. Ante if the speed is equal to this, then and only then it will be in a circle. Good, very good, very good, very good, very good, Lalita, very good. So then and only then it will be in a circular motion. If you increase the speed, it will leave the motion. If you decrease the speed, it will get attracted and collide with the particle. Understanding? Yeah, no. Spandana, no. No. Chalo. Next. Okay. So terms gurinchi maatladtam. Chuskondi. Terms is circular motion. Angular speed usually represented by omega. Angular acceleration alpha. Angular displacement ante theta. Now I am not explain you. Okay, fine. Chuskondi. This is the center, okay? This is the center and this is my pencil. This is the pencil, kada? Okay. Now what I am doing is I am keeping one point fixed and I am trying to move it in a circle. Chuskondi. Something like this. Initially, pencil was like this, sir. Final scenario, look, the pencil has tilted, kada? How much angle covered? Yes. How much angle covered? Theta. This angle ni we will call it as angular displacement. Andariki ardham cheskondi. Okay, angular displacement. Sir. Yes, darken. Very good. Angular displacement at theta. Theta is what, sir? The angle it has covered. Sir, displacement we also have seen in one dimension, kada? Displacement. So displacement is always valid for a single particle. Chuskondi. Displacement is always valid for a single particle. Kani a rod lo there are infinite amount of particles, kada? Yes. So that means ఈ మొత్తం కోసం the value of the displacement will be different. చూసుకోండి, this particle has moved only this much displacement. ఎక్కడ వచ్చి you talk about this particle displacement. I'll change the color. Okay, I'll change the color. It has moved this much. Displacement is this much. ఎక్కడ వచ్చి this much displacement. చూసుకోండి. Oh, increasing. Increasing. చూసుకోండి రా. These are the displacement. Okay, sir. So that means as I am coming away from the center, displacement of each and every particle is increasing. Ante kada? So that means, sir, let us call the displacement as L. Sir, let us call this displacement. What displacement? Total displacement. Distance, you can say distance. Okay, distance. Okay, you can call the total distance to be equal to L. Chuskondi. As I am taking the away particles, and as I am going away from the center ante enti ra? Radius is increasing. Ante as I am increasing the radius, the displacement is also increasing, kada? So that means linear distance is directly proportional to radius. You can also say, sir, it is equals to theta into r. It is a constant. Are you understanding proportionality? Constant theta. So that means, sir, length is equals to r into theta. Point number 1. Length ante linear distance. Similarly, theta ante angular distance. Okay. Okay. Yeah, I will have to block some people. Okay. Give me 1 minute. Yeah, will be blocked so much. Okay, whoever is talking some nonsense, they will be blocked, not tolerated. No. The thing is that the laptop is not with me right now, so I have to inform the other people, admins actually. Okay, done. They will be blocked for sure. Okay, for sure. Don't worry. Don't worry. Okay, shall we start? Continue. So let's continue. Okay, let's continue. And ignore for now. Okay, some idiots have broken to our chat list. Okay, you skip for now. Okay. So, yeah, Spandana, you're saying something. Let us start. Okay. Yeah, done. Warrior of liberation. Done. He'll be blocked. Okay. No, Hemant Kumar, I'm not talking about you, Ray. Okay? People who are abusing, who are using bad words, for them I'm telling that. Chalo. So what is the relationship between angular displacement theta and linear displacement L, Ray? So you can simply say, sir, linear displacement L is equals to R into theta. Point number 1, andariki ardham cheskondi. It has same relationship with velocity also, acceleration also. Ante kada? Okay. Good. Okay. So you can simply say, sir, this is the linear displacement. Linear distance covered. Okay. Distance covered. And this is the angular distance covered. Kada? Okay. Next, let us talk about angular speed. Hey, let us talk about angular displacement. So we talked about angular displacement. Now we are going to talk about angular speeds. You are distracting me a lot. Okay, the people who are spamming in the chat. Kill you. Okay, I'll kill you. Why would I be? Okay, chalo. Next. Yes. So let us talk about angular speed. The flow was very good, Ray. Some idiots have broken the flow. Every single day I try to be as calm as possible, but these people, they make me angry anyhow. Okay. Good. What is angular speed, sir? Angular speed ante how fast the particle is moving. Chuskondi, it's moving very slow, kada? It's moving very slow. Can you say this? It's moving very slow. Ante angular speed is very slow. Now it is moving very fast. Ante angular speed is very fast. Are you understanding? They the same principle ra. Chuskondi. So if this is my rod ray, I don't like the color actually. Okay, let us change the color. Okay. So if this is my rod ray, okay, this point is fixed. Now this rod is rotating. If it is rotating very slow, ante angular speed is slow. Okay, ante angular speed is slow. But if this rod is moving very fast, ante angular speed is fast. Sir, what is angular speed, sir? Angular speed into enti, sir? You can simply say if it is moving at a constant angular speed, exactly like in one-dimensional motion, angular. Okay. So, okay. Hey, in 1D we have linear acceleration, angular acceleration, linear speed, here angular speed, linear displacement, here angular displacement. Ante kada? Okay. Same, similar processes. What is speed rate? Distance by time. Sir, in linear, distance by time. Ekkada uchi, sir, angular speed omega is equals to angular displacement by time. Ante kada? Ade. in 1 second how much angular displacement is happening, we call the same amount as angular speed. Ante kada? Yes. Okay, good. So theta is the angular displacement. Ante enti ra? Theta ki value cheppu re. What is the value of theta re? Theta value L by R kada. L by R చూసుకోండి from here sir, theta is equals to L by R re. Sir, theta is equals to L by R. Okay. Substitute. Okay, so sir, omega is equals to L by R divided by T ante kada. So you can simply say, sir, omega is equals to L by T into R. L by T re, distance by time, linear speed kada. Linear speed, distance covered, చూసుకోండి. For every particle, distance covered is different. Hey, are you understanding? For every particle, distance covered is different. Similarly, for every particle, linear speed will be different. Good. Sir, so sir, omega is equals to this term we call it as V. V ante linear speed, చూసుకోండి. V ante linear speed divided by R ray. What is R ray? R is not radius. Hey, R is not radius. R is the distance of each particle from the center. చూసుకోండి. This is my distance R రా, చూసుకోండి. ఈ పార్టికల్ గురించి మాట్లాడుతున్నాం. For this particle, R is the distance of this particle from the center, and V1 will be different. ఎక్కడ వచ్చి V2 will be different. ఎక్కడ వచ్చి V3 will be different. కానీ omega, angular speed for all the particles will be same. Similarly, angular displacement for all particles is same re, theta. But distance covered is different. చూసుకోండి. Small distance. Yes, good, very good. Okay. Hi Raju, very good evening. Yeah, Vikshita. Okay, I'll remember. Okay, I will remember. So you can simply say, sir, omega is equals to V by R. Leda, we have also one more formula. Omega is equals to theta upon time. Ante kada? Yes. So these are the two formulas for the angular speed. Depending upon the condition, you can take whichever is suitable. Ante kada? Next. Angular acceleration ra, చూసుకోండి. Hey, represented by alpha ra. Alpha. Ade, in linear, how did we do re? Sir, acceleration is equals to delta V by delta T. Yes. Sir, in linear motion, what did we say, sir? In linear motion, we say acceleration is equals to delta V by T ante kada. Ante A is equals to delta V re, V minus U, final minus initial divided by time kada. Simplify chesina tarvata, I was getting some this formula re, V is equals to U plus AT ante kada. What is V? Final speed. What is U? Initial speed. What is A? Acceleration. What is T? Time. Kani apply the same in angular form also ra. Cheppandi. Sir, V ante final speed. So what I am telling, sir, angular acceleration alpha is equals to delta V ante delta omega divided by time. చూసుకోండి. So if this is my rod and I am rotating it. So initially the rod was moving smoothly, no jerk, no angular acceleration at all. But suddenly someone hit చేసిన తర్వాత what happened is it got accelerated and its speed increased. Are you understanding? The speed increased all the times. Okay, Lalita, all the times we can write V is equals to R omega. Yes, all the times. Whenever it is a circular motion, its linear speed is equals to R into omega all the times. చూసుకోండి. Here simple form kada. This R is here, sent there. So V is equals to R omega. You can say that also. At all the times in a circular motion, we can write V is equals to R into omega. Ante kada? Good. I'll give you one more example. చూసుకోండి. Okay. So idena rod, this is the hinge point ray. Hinge ante telusa? Hinge ante the point that is fixed. Okay. So the angular speed omega is equals to 2 radian per second. Andarki చూసుకోండి. Now what I am asking you is, I have 4 different points ra. Point number A ekkada undi. Point B ra here. Point C ray here and point D ray here. చూసుకోండి. Okay. So if omega is 2, I will tell this length is 2 meters. ekkada vachi this length is 4 meters. and the total length of the rod is 8 meters. So question is find speeds of all the points ra, VA, VB, VC, VD. Cheppandi. Rotation kada, moving some angular speed, moving with some angular speed kada. No, angular velocity already covered, Joshna. Angular velocity covered chesin tarvata I have meant to angular acceleration, okay? Okay, good. So sir, let us talk about velocity of A. So velocity of A is equals to omega for all the particles. No doubt, undoubtedly for all the particles omega is the same ra. Chuskondi. I am writing in the answer only. Chuskondi. I will write in the answer also. Undoubtedly omega is same. Omega ante enti ra? Angular velocity kada for all the particles re. He has been blocked, okay? Ramcharan has been blocked. Good. So sir, omega is same for all the points, but velocities or speeds will be different. So speed of point A is equals to omega into distance of point A from center and the radius of A from the center. Similarly, Chappora, speed of point B is equals to omega into distance of point B from center. Omega, speed of C, speed of point C is equals to omega into distance of point C from center, and similarly speed of point D is equals to omega into distance of point D from center. Cheppandi values cheppandi. So sir, V of A is equals to omega into omega ki value kuda pettora. We can simply say sir 2 into distance of point A from center. Ide center kada, so distance is 0. Ante speed of point A is 0 ra. Ekkada ochindi cheppandi. So omega is 2. Distance of point B from center. Center is A. Chuskondi 2 meters kada. So 2 into 2 ante 4 meters per second. Ide point B ki speed ra. For speed C cheppandi. Sir, 2 into distance of point C. Distance of point C is 4 so that means 8 meter per second. It is for the point C. For D cheppandi ra. Omega is same for all kada. Yes. So omega into R. So 2 into 8 ante 10 meters per second. Hey, Ramcharan has been blocked na re. Why are you asking about him now? Okay. Don't spam. Good. Very good. Lalita, very good. Okay. Great. Omega ardhamaindi. Omega ante the angle by which the rod is rotating in 1 second. In 1 second. Good. Darken. Very good. Okay. Omega finished. You can apply V is equals to R omega at all points for each and every point, but it should be in a circular motion. Ante kada? Yes. Good. Lalita, very good. Go nut. Good. So ekkada vachi angular acceleration gurinchi maatladutunnaru cheppandi. So sir, in this scenario omega was constant kada, 2 radian per second re. But what if omega is also increasing ra? Like here. Chuskondi. So initially the rod was like this, moved with omega is equals to 2 radian per second. So 2 seconds tarvata the rod moved something here, something like this. Ante kada? Not for 2 seconds. You can simply say after some time the rod moved here. Ekkada vachi it is getting some force re. So for example, let us say someone is hitting it like this. Hit chasina, what happens is the angular acceleration will be there. Ante the speed that was there 2 radian per second, slowly it was going re. You hit chasi, the speed will increase kada, ante acceleration is there, angular acceleration is there. So let us say at t is equals to 0.2 seconds for this interval ray. Hey, for t is equals to 0.2 seconds, you have pushed the rod, and after 0.2 seconds the new angular speed that was originally 2, it became to 4 radian per second. Are you understanding? So cheppandi, angular acceleration alpha is equals to change in omega divided by change in time. What is change in omega? 4 minus 2 kada, divided by how much time it took to change, how much time you pushed it, for how much time you push the rod. 0.2 seconds. So 0.2 ante kada. So 2 divided by 0.2 ante 10 radian per second squared. Finished. I hope you are getting it right. Okay. Alpha is equals to delta omega upon t ante alpha is equals to final angular speed minus initial angular speed divided by time. What time, Ray? What time? The time for which you were pushing the rod. That means the time for which you were hitting, pushing the rod. Good. Next, number of rotations. Chuskondi. Number of rotations. Let us start from basic part. Hey, chuskondi. So, this is a hinge point. Hinge point is the point that is fixed. It is my hinge point. Now, I am rotating the rod, something like this. Ante kada? So, this point is fixed. Okay, I am rotating something like this. Chuskondi. Sir, initially the rod was like this. Koncham samayam tarvata the rod came to this position. Cheppandi, how much angle it has covered? Sir, theta is equals to 90 degree. Ante kada? Yes. Yes. Hey, dan tarvata I am also making this rod come again in this position. Ippudu the rod is something like this. Cheppandi. How much angular displacement? How much angle it covered? Idi 90, idi 90. Total angle ante 180 degrees. So this is also 90 kada. So total angle cheppandi ra. So total angle is 180 degrees. Ante pi radians. Pi radians ra. Hey, chuskondi ra. Pi radians. Okay, sir. Again after some time, malli I am moving this rod something like this, right? Something like this. Choose. Initially rod was like this. I moved it. It came to this position. Again, I moved it. It came to this position. Again, I am moving it. It is coming to that position. Cheppandira. Malli, this angle is 90 degree kada. So theta is equals to 90 degree. Hey, total displacement cheppura. The rod was here. Moved completely. Something like this. Ante kada. So 270 degrees. 270, 270, 270, 270. Okay, I am not stopping here also. Right? Again, I am pushing this rod here. Ante the rod started from the same point, completed one complete rotation and came to this point. Ante one rotation endi kada. So one rotation. Cheppandi, one rotation ante how much angular displacement? Sir, 90, 90, 90, 90, 360, 360, 360. Ante one rotation ante 360 degrees. That means 2 pi radians ra. Are you understanding? Okay, so that means if one rotation is there, angular displacement enta ra? Angular displacement. Cheppandi. Angular displacement ante theta kada? Yes. So angular displacement ante theta is equals to 2 pi. Chuskondi. One rotation kosam theta ki value, it is always equals to 2 pi. Okay, sir. For one rotation, it is 2 pi. For two rotations, 4 pi. For three rotations, 6 pi. Okay? Okay? Okay. Sir, for one rotation, sir, for one rotation, chuskondi. For one rotation, n is equals to 1. And it is 2 pi kada. Sir, n is equals to 2, sir. That means 4 pi re. Hey, n is equals to 3 re. Hey, that means 6 pi re. Sir, n is equals to n ante 2n pi rotations. Hey, 2n pi will be the angular displacement. For n rotations, 1, 2, 3, 4, 5. For n rotations, 2n pi will be the angular displacement theta. Gurtupettukondi. Okay? Next. RPM to angular speed ra. Chuskondi. RPM ante enti ra? RPM ante rotations per minute. Per minute ante enti ra? Per minute ante 60 seconds kada? Yes. Per minute ante 60 seconds. Ardhamaindi? That means, sir, 1 RPM అంటే 1 rotation చూసుకోండి రే చూసుకోండి రే అంటే 1 rotation in 1 minute అంతే కదా 1 RPM అంటే 1 rotation in 1 minute 1 rotation అంటే angular displacement ఎంతరా 1 rotation అంటే theta is equals to 2 pi radians in 60 seconds kada. Yes sir, 2 pi radians is 60 seconds. 60 seconds. Hey cheppandi ra, angular speed how much re? Sir omega is equals to theta upon t kada. Theta is 2 pi divided by 60, that means pi divided by 30. Sir, if 1 rotation per minute ante pi by 30. Good. So 1 rpm is equals to pi by 30 radians per second. Similarly cheppora, hey 2 rpm re, hey 2 rpm ante 2 pi by 30 hey radians per second. Sir similarly sir n rpm, sir n rpm ante n pi divided by 30 radians per second. Kada, finished. You got the conversion from rotation to theta, from rpm to radian per second. Getting it? Okay. I think it's clear for all of you. Good. Now ఇప్పుడు let's talk about time of rotation ra. Time of rotation అంటే ఏంటి రే? Time of rotation అంటే ఏంటి చెప్పండి అందరికి. Sir, it is covering the total displacement and I have to talk about the time ray. Time is, sir, distance upon speed. Distance upon speed kada. Okay, so if the radius is r ray, చూసుకోండి అందరికి. If the radius is r, how much distance, sir? Circumference. Sir, time is equals to distance divided by speed ray. How much distance, sir? Sir, 2 pi r. Hey 2 pi r divided by speed ante v kada. Yes, speed is v re, v is equals to r omega. Okay, v is equals to r omega. So sir, time period is equals to 2 pi r divided by v is r omega ante r gone. So that means, sir, 2 pi divided by omega. Or else leda you have one more way to prove it ray. What is the way, sir? Sir, omega is equals to theta upon time kada. What if theta is complete rotation ray? For complete rotation చూసుకోండి. For complete rotation చెప్పు, what is the value of theta ray? For complete rotation theta is equals to 2 pi kada. Theta is equals to 2 pi. Substitute ray only. So omega is equals to theta value ray, theta అంటే 2 pi divided by total time t. ఎక్కడ నుంచి you also get time is equals to 2 pi by omega. Remember, ఇదే నా time period of rotation, 2 pi by omega లేదా 2 pi r by v. You have two different formulas. Okay, next, equations of motion ray. You have three equations of motion in linear ray. Good. You have three equations of motion in linear motion. Linear motion lo kuda you have three equations. What are the three equations, sir? Let us compare these linear equation with rotational equations ra. Cheppandi. So linear equations with rotational equations. Number one sir, v is equals to u plus at. Hey, what is v ray? Final speed. Ekkada vachi, sir, it becomes final angular speed omega f is equals to initial angular speed omega I plus linear acceleration. Ekkada it will become angular acceleration. Equation number 1. Ante kada. Second equation ra. Cheppandi. Equation number 2, sir. S is equals to ut plus half at squared. Ante kada. So that means shift and convert the same thing ra. Linear displacement, angular displacement is equals to initial speed kada. Ikkada kuda initial angular speed omega I into t plus half into linear acceleration. Sir, linear acceleration ekkada vachi angular acceleration ante. And lastly, the third formula ra cheppandi andariki. It becomes v square is equals to u squared plus 2as. Cheppandi here tell me, sir, v ante final speed, ekkada kuda omega ante final omega is equals to u ante initial, so initial plus 2 into angular acceleration into angular displacement. చూసుకోండి, these are the formulas. ఇప్పుడు you will have to understand what formula to be used at what time. Hey, he came again. This is spamming again, ra. Okay, let us move. Chuskondi. Fan starts from rest and attains the angular speed of 4 rpm in 4 seconds, ra. The angular acceleration of the fan is what? Starts from rest ante enti re? Starts from rest ante initial angular speed is 0. Point number 1 to be noted. Extract cheskondi mottam information you have to. Where angular kada, angular acceleration rate. Okay, alpha ki value I want that. Sir, omega initially is 0, angular speed of 4 rpm re. Hey, I told you the formula to convert 4 rpm into radian per second, ra. Cheppandi. Sir, n rpm is equals to n into pi by 30 radian per nth. Okay kada? Yes. So directly multiply re. 4 pi by 30 kada ante 2 pi by 15 radian per second. Ide na final angular speed. Point number 1 vachindi kada. You substitute re. Omega f is equals to 2 pi by 15 radian per second. Ante sir, you apply the same formula. What formula? V is equals to u plus at. Omega f cheppandi ra. Sir, it is 2 pi by 15 is equals to 0 plus alpha into how much time re? 4 seconds. So 4. Ikkada nunchi 2 pi by 15 is equals to 4 alpha. Sir, alpha is equals to 2 pi by 15 into 1 by 4 kada. So that means gone. It is equals to pi by 30 radian per second square. Ide na angular acceleration alpha. Good. Next. Directly NEET re. Hey, directly NEET re. So let us discuss few more questions, ra. Okay, let us discuss few more questions. Number 1, I have to make it by myself. Okay. Of 30 re. Hey, 30 rpm. Okay, 30 rpm. Next, if చెప్పండి. close, dark and close to the answer, okay? Eight. Let us see. Okay, let's see. చెప్పండి. Go not instead of dividing you multiplied it, okay? Okay. చెప్పండి రా. Sir, omega initial is 0 kada. Why? Hey, starts from rest kada. Yes. Attains angular speed of 30 rpm re. Hey, omega f re. Omega f is equals to 30 rpm. Kani, I don't want the angular speed in rpm re. I want in radian per second kada. So how will I do re? How will I do? Sir, omega f is equals to 30 into pi by 30. Ante pi radian per second. Finished kada. Now I have omega initial, omega final, angular acceleration also. I want theta. So sir, v square is equals to u square plus 2as 2 alpha theta. Ante kada. V square ante entira pi square is equals to omega initial square is 0 square plus 2 into alpha ki value cheppora pi by 32 kada. Yes, into theta re, into theta. Good. So ఇక్కడ నుంచి what you can say is, sir, pi square is equals to pi by 16 into theta. Sir, pi gone, sir. Send that 16 this side re. So sir, 16 into pi is equals to theta. Theta ante 60 pi re. 16 pi. I want number of rotations. So one rotation ante 2 pi. One rotation ante 2 pi. Two rotations ante 4 pi. Four rotations ante 8 pi. 8 rotation ante 16 pi. Or you simply divide it by 2 pi re. Hey, n is equals to theta by 2 pi. That means 16 pi by 2 pi is 8. The 8 rotation it might have completed. Good. Go not very good. Okay, good. Next. I think that's more than sufficient. Okay, that's more than sufficient. So let's come to the centripetal force concept, the initial concept that we discussed. Okay, let us come to the initial concept that we discussed. Cheppandi. A bob is whirled in a horizontal plane by means of a string with an initial speed of omega. The tension is T ray. The tension is T. Chuskondi. Bob is there. Omega speed is there. Angular speed omega ra. Hey, chuskondi. Angular speed ante omega. And the tension in the string ray. Ippudu the tension is T ante kada. What is it doing now? Ippudu he is changing the angular speed of the bob. Ante omega nunchi it is jumping directly to 2 omega. Kani sir, for this object to be in speed ray, let us say mass is m, okay? So sir, for this block to be in a circular motion, some force is required. How much force required ray? mv square by r. Chuskondi. Centripetal force kada. This is the required force to be in a circular motion. Sir, v is what, sir? R omega. Ante m into r omega whole square divided by r ante m into omega square divided by r. Idi kuda centripetal force ki formula ra. You remember, formula ante required value m omega squared by r. So sir, tension is providing that much of required force. So in this scenario, sir, tension is equals to m omega squared into r. Ante kada. But what we are doing, right? We are increasing the angular speed to 2 omega. Cheppandi. So if the angular speed is 2 omega, ra, cheppu. If the angular speed is 2 omega, same condition kada, mass is same, radius kuda same ra. Ippudu how much force is required, sir? M omega squared r ante centripetal force is m into omega value cheppura. Omega value is 2 omega squared into r. Ante m into 4 omega squared r ante 4 into m omega squared r. This is the required value. Now, if it is moving with 2 omega, this is the required force. This is the required force kada? Yes. So let us say this is my net value or new value T new. New tension. What is old tension, right? Old tension is this. What is new tension, right? New tension is this. Ratio teeskondi. Cheppandi. So tension new divided by tension old is equals to tension new ki value 4 m omega squared r divided by m omega squared r gone re, and T new by T old is equals to 4. You send this T old that side, sir, new tension is equals to 4 times old tension. Ante. That means 4 times old tension, 4T. Next. Hey, next question, ra. Chuskondi. Particle moving with uniform speed in a circular path maintains velocity and acceleration gurinchi maatladali. Sir, we have discussed vectors. Discuss chesina kada. Vectors lo why confusing? Don't know why confusing. Why confusing? Chuskondi. Initially, this is my initial condition, okay? Initial condition ante enti ra? Initial condition lo there is this mass m. Hey, mass m is there moving with angular speed omega, a radius is r. Ide na initial condition. Final condition lo same mass, same circular path, kani the only change is the angular speed omega. Here it is 2 times omega. Same speed. No, same mass and same radius ra. Tell me the required forces in both the cases. Cheppandi. Required force ante centripetal force, sir. Sir, required force ante centripetal force, that is equals to m into omega square into r. Remember the formula, okay? Only the formula. Ekkada cheppandi. Omega is what, re? Whatever angular speed is there. Come here, cheppu. Required force is equals to m into omega. What is omega, re? Now it is 2 omega. New omega is 2 omega. Angular speed is 2 omega. So 2 omega whole square into r. Cheppandi. Clear till this point? So ante this required force will be provided by the tension kada? Yes. So that means the tension will provide here. Ante T2. Second scenario lo tension kada? T2 is equals to m into, simplify it, 2 square is 4 omega square into r. Ante 4 m omega square r. This is the value of the tension in the new scenario when the speed is increased. Speed increase chesi mundu, what is the tension value? So tension is equals to m omega square into r kada. It must balance the centripetal force, re. Tension force is providing it. Now see the relation. T is m omega square r. T is m omega square r. Sir, T is m omega square r. M omega square r, sir. T is m omega square r. And T2 is equals to 4 into T. Finished. T2 was asked in the question. Next. Or you have any doubts? Feel free to ask. Okay, next. Okay. So, circular motion is there, ra. Chuskondi. Ide na circular motion. Kada? Okay. So, in that, this is a particle, right? Now, velocity and acceleration guruji cheppali. Ante velocity is a vector, acceleration is also a vector, sir. Ante velocity and acceleration both have directions also and magnitudes also. The direction, equal vectors. Hey, constant velocity, Constant velocity, constant and varying ante enti ra? Constant velocity ante equal velocity. Equal velocity ante vectors. Two vectors are equal when their values and their directions are equal, ante kada? Yes. Let us imagine two different instances ra. First instance is here re and the second instance is here re. Cheppo ide na center kada. So centripetal force ki direction cheppandi andariki. Centripetal force ante centripetal acceleration. Okay, ade the only acceleration it is asking, centripetal acceleration chuskondi. So the direction of centripetal force is something here re. Ikkada kuda the direction of centripetal force is something here re. For sure the value is same. All the times the value of centripetal force must be mv squared by r. Chuskondi. The value of centripetal force must be mv square by r. Kani directions re, directions changed kada. So that means it cannot be constant acceleration. Where is constant acceleration? Gone re. Why sir? Because its direction changed. It cannot be constant acceleration. Point number 1. Ante kada, fixed. So that means sir, constant acceleration is not talking here also. So this option I'll delete also. Endukante it's not talking about constant acceleration. Okay, if you don't want that, you keep it. Let us talk about velocity now. Okay, let us talk about velocity now. Chappo, velocity is always in the tangential direction. So ide na velocity v1, ide na velocity v2. Hey, values are same, but direction. Hi, Bharat Veda. Hi. But direction of v1 is here and direction of v2 is there. Ante no constant velocity also. So constant velocity gone re. Constant acceleration also gone re. Constant velocity also gone. Ante varying velocity, varying acceleration. Only in terms of direction. Okay. Only in terms of direction. You remember this. Leda magnitude of velocity is always constant in uniform circular motion. Okay, it is always constant in uniform circular motion. At the same time, magnitude of acceleration also constant, but it is not talking about magnitudes. Okay, it is talking about overall ante deentlo value kuda vachindi, direction kuda vachindi. Okay, next. Good. Next, okay, a constant torque. If you remember this, good. If you don't remember this, you remember one formula. Torque is equals to I into alpha. Hey, freshers. Skip this question. Droppers, you can do it. Okay, droppers, you can do it. Cheppo. Torque is how much re? 100 is equals to I, moment of inertia. Cheppo, value intira 300 into alpha. So ekkada nunchi alpha is equals to 1/3 radian per second squared. Finish. Okay, second square. Okay. Yes, go nut. If the direction is different, that means we say vector by itself is different. Even for a second, the directions is different. That means we will simply say the vectors are different. Understanding? Sir, alpha value I got it, sir. About an axis passing through center, starting from rest, angular velocity after 3 seconds. Angular velocity after 3 seconds. You have alpha. Starting from rest kada, you have omega initial is equals to 0. So you have alpha is equals to 1/3. 3 seconds tarvata, you have to find angular speed final ra. Cheppandi. Hey, time is how much re? Time is equals to 3 seconds. What formula I have to use re? Sir, omega f v is equals to u plus 80 ante kada. Omega final naku teliyadu ra. Kani omega initial telusa kada 0 plus alpha value cheppandi ra 1/3 into time is 3 sir. So 3 gone ante 1 radian per second is the angular speed at the end of 3 seconds. Okay. Next. Okay, 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 okay. Okay, sir, a particle starts from rest, moves in a circle of radius r, attains a velocity of v naught in nth round. Oh, nth round ante angular displacement entira? Angular displacement enti? Nth round kada? Nth round. Naku nth round ante angular speed entira? Sir, for first round, angular displacement is 2n. For second round, 2 pi. For second round, it is 4 pi. For third round, it is 6 pi. Ante theta is equals to 2n pi. Formula only, re. 2 pi n or 2n pi, whatever you want to call. You can call it. Okay. This is my angular displacement. Rotating first, second, third, fourth, fifth, sixth round ante 2 pi tone increase cheyandi. Okay, sir. Nth round ante angular displacement vachindi kada. Okay. Starting from rest, sir. Starting from rest ante omega initial ki value 0 ra. Chuskondi. Radius entira? Radius is r kada. In a circle of radius r, sir, radius is equals to r. Velocity of v naught, re. Hey, final velocity of v naught. Sir, v is equals to r omega. Ante v final is equals to r into omega final. Sir, ekkadi nunchi omega final is equals to v final by r. Ante kada. Ante v naught by r, re. Ante. You have final velocity. Angular. You have final angular speed. మీ దగ్గర initial angular speed కూడా ఉంటుంది. You can also have theta. What formula to use it? What is it asking? Angular acceleration. చెప్పండి. Sir, v square is equals to u square plus 2as. F square is equals to plus 2 alpha theta. Okay. Next, omega f ki value cheppora. Sir, v naught square divided by r square is equals to, sir, 2 alpha theta. Omega initial gone, re, 0 kada. Sir, 2 pi n alpha theta ki value re ochindi into alpha. So, sir, ekkadi nunchi alpha is equals to v naught square divided by 2 pi n directly in the denominator and r square remaining. You write it like this, re. Cheppandi. Arre, 2 alpha theta, re. 2 alpha theta and it becomes 4. Okay? Option number A. Next. Good question. Question. I'll give you 2 minutes time, re. Try cheskondi andari. Particle moving in the circle of radius r within you to come. Particle will. So our angle of projection is oh, let us see it. Actually, it's not that much difficult actually. Easy only. Easy only. Cheppandi andariki. Hi. Your friend. Hi. Okay. Sir, particle moving in a radius, uniform speed, takes time t to complete one rotation. Ante time t for one rotation is equals to, sir, total circumference, sir, 2 pi r divided by speed v ante kada. Yes. So ikkadi nunchi you can simply say, sir, speed v is equals to 2 pi r divided by total time. Equation number 1 I got it, right? Ippudu ఇదే స్పీడ్ తోనే I am projecting it as a projectile రా చూసుకోండి. So with the same speed I am throwing the object v speed, okay, and it is going and it is falling somewhere here. Ante maximum height is h, but it has given h is 4r. Sir, h is equals to 4r. Ante height ki value formula cheppura. Sir, height is equals to u square sin square theta divided by 2g. Kani h is 4r. Sir, 4r is equals to u square sin square theta divided by 2g. Ante send it there. Sir, 8gr is equals to u square sin square theta. Ante kada. Now, I have one thing in my mind, re. Chuskondi. Okay, let us do it by the traditional method only. Eppudu substitute the value of u, re. U ante speed kada. Speed is this. Cheppandi. Sir, 8 into g into r is equals to u square ante mottam ki square ra. 2 pi r whole square ante 4 pi square r square divided by t square into sin square theta. Ante kada, you send everything this side. Cheppu. So sir, 8gr into t square divided by 4 pi square r square is equals to sin square theta. 4 ones are 4, 4 twos are 8. R are also gone, re. So sir, 2gt square divided by 2 pi square r, not 2 pi square, 2 to gone kada. Yes. So divided by pi square r is equals to sin square theta. That means take the square roots. Square roots. So that means sir, sin theta is equals to root ante power half, re. Hey, square root ante power half. I am writing already. Chuskondi. So it is equals to 2gt square divided by pi squared r. Ante theta is equals to sin inverse of 2gt square divided by pi squared into r to the power half. Option right. D kada. Good. Mysterious. Very good. Confidence is the key. Okay, Lalita, confidence is the key. Next, Chuddamama. A ball is thrown vertically. Now. Your circular motion questions are over. Okay, your circular motion questions are over. So it's just the revision or the repetition of the normal questions, including your horizontal projectile. Good. Or your projectile motion. Okay, let us take this question. Thrown vertically downward with velocity of 20 meters per second from the top of a tower. So, this is a tower. Chuskondi. So, this tower top nunchi, I am throwing this ball with the speed of 20 meters per second. So, this is the ball. Speed is 20 meters per second. Okay. It hits the ground after some time with a speed of 80 meters per second. Height kavalira. Okay. Final speed how much? Final speed v is equals to 80 meters per second. What do I want? I want this height. Hey, what formula to use? It's a kinematics 1D question actually. Okay, what formula to be used? Sir, v square is equals to u square plus 2as. Sir, v square is equals to u square plus 2as. V square value ante 80. 80 squared ante 6400. Your calculation must be very fast. Okay, 20 squared is 400, sir. Plus 2a ante 20 into displacement h. H or height s. Yedaina teeskochu. Sir, 400 gone, sir. So 6000 is equals to 20 into s. Ekkad nunchi, sir, s is equals to 6000 divided by 20 ante 300 kada? Yes, 300 meters. 300. Teeskondi re, chuskondi. Next question. Okay. Two bullets fired from horizontally and simultaneously towards each other from the roof of two buildings 100 meters apart. Ante two buildings. Building number 1, building number 2, building number 2. Distance cheppu 100 meters apart kada. So the distance between these two is 100 meters. Two bullets are there, fired horizontally and simultaneously towards each other. Hey, ekkad nunchi, top nunchi, this bullet fired here and this bullet fired here. Ante kada? Right? Yes. Sir, height 2 meter, same height 200 meter. Ante idi height 200 meters. This height is also equal to 200 meters. Andariki chuskondi. So this is also 200 meters. Okay? At the speed of 25 meters per second. Ante this is 25 meter per second. Idi kuda 25 meter per second. Sir, what is it asking? When and where the bullets hits. A very symmetric question kada. It is a symmetric question, Ray. Everywhere it is symmetry. Height same, speed same, bullet same, distance same, everything. So that means the bullets will hit at the midpoint. In air only, but somewhere midpoint. Endukante Same speeds kada, 25, 25, 25, 25, 25, 25, same distance covering, same distance. Ante this bullet will cover 50 meters. This bullet also in horizontal, this bullet also covers 50 meter distance. Ante kada, speed enti ra 25, distance enta ra 50. Is there any force acting in the horizontal? No, no force. Okay, no force. Ante distance is equals to speed into time. Ante distance is 50 is equals to speed is 25 multiplied by time t. Ekkad nunchi you get the value of time is equals to 50 upon 25. That means it is equals to 2 seconds ra. So 2 seconds tarvata they'll not collide is gone. Okay, after 4 seconds also gone ra. Chuskondi. Actually this much information is sufficient. In 2 seconds they'll not fall much kada. So I have height of 20 meters, very less, and height of 180 meters. So 180 meters and the bullets have not fall that much in 2 seconds. So that means the bullet will still be in the air only, somewhere near to the top only, because 2 seconds only have passed. Okay, good. So 180 meters, but if you want the total answer, sir, what should I say, sir? Sir, in 2 seconds, sir, in 2 seconds, S is equals to half 80 squared. Why half 80 squared? Ut is 0, U is 0, U is 0. Sir, S is equals to half into what is A? A is 10 into T. How much T? 2 seconds. 2 seconds ante 4. 2 square is 4. Sir, gone. Ante 20 meters distance they have covered. Distance covered is 20 meters. Ekkada kuda distance covered is 20 meters. Total height 200 kada. So remaining height cheppandi ra 180. 180. Okay, next. So two particles A and B moving in with uniform circular motion in concentric circles. Radii R1, R2, speeds V1, V2. The time period of rotation is same. Radio not matters. Does not matter. Chuskondi. What is it asking? What is it asking? Angular speed omega 1 by omega 2 kada. We just saw the formula for time period. What is the formula for time period? Good. Hey, T is equals to 2 pi by omega. Ante kada. This is the formula we saw. You remember time period formula 2 pi by omega. Sir, T1 is equals to T2. Ante 2 pi by omega 1 is equals to 2 pi by omega 2. When is it happening? When does it happen? When omega 1 is equals to omega 2 ante omega 1 is equals to omega 2. That means omega 1 by omega 2 should be equals to 1 by 1 ra. Chuskondi. No need to draw, visualize all those figures only. Okay, time is 2 pi by omega only. Good, very good. Lalita, very good. Okay, Gonat, very good. So times are same. So what the student does is trying to draw concentric circles, then write the formula T is equals to 2 pi r by V. Sir, V I don't know, V is r omega. Sir, let us substitute in the formula 2 pi r by V, omega into r cancel, then it comes 2 pi by omega. You directly remember the formula for time period. Ante kada, finished. Next. World in horizontal circles. Horizontal circles ante telusa. The heavier one in radius r2, lighter one in radius r by 2. Yes, tangential speed of the lighter stone is n times that of the value of the heavier stone, where they experience the same centripetal forces, the value of n. Directly formula cheppura. Centripetal force ki value entira. Good. Yes, V1 by R1 is equals to V2 by R2. Lalita. Centripetal force, sir. Centripetal force is directly equals to m into v square by r. Ante kada. Tangential speeds given ra. Lighter stone is n times. Ante I have two different stones. First stone is a lighter stone. Ante mass m. Second stone is a heavier stone ra. Cheppu. Ante mass 2m kada. Yes. Sir, they both have same centripetal force. Ante F is equals to F kada. Cheppandi. Sir, mass m. Sir, speed of light stone, sir. Sir, speed, the tangential speed of light stone is n times that of the heavier stone. So if I am calling the speed v here, it becomes n times ante n into v ante kada. Same thing. Good. So sir, m into speed square. What is the speed? NV. So sir, speed ante nv whole square divided by r. Radius ra, radius for mass m, what is the radius re? Radius r by 2 చూసుకోండి. And for mass 2m radius is r kada. No, lighter one is radius r re. Hey, lighter one is radius r, heavier one is radius r by 2. Radius gone, mass 2m, speed square ante v square only. అంతే కదా, చూసుకోండి. సార్ m into n square into v square divided by r is the centripetal force for lighter ball. Heavier గురించి చెప్పండి రా. So this 2 comes up, right? 2 into 2 becomes 4. So 4m v square divided by r. Both forces same kada. Equate, equate. How will you equate, sir? You assume, I have equated it. Okay, I have equated it. Equal. Ante m gone. V square gone. R kuda gone re. N square is equals to 4 re. Hey, n square is equals to 4. Ante n is equals to how much re? 2. 2 kada. Yes. Good. Very good. Next. Okay. N square is 4. Not n. N square is 4 and n is root 4 ray. 2. Okay, good. Particle is moving with a constant speed v ray in a circle. Alright, wrong circle, right? And drawing skills are not good, okay? You just visualize it. What is the magnitude of average velocity after half rotation? Half rotation tarvata average velocity kavalira. Hey, చూసుకోండి. Velocity is equals to displacement by time ray, not distance, okay? Displacement by time. అందరికి చూసుకోండి. For half rotation, velocity is displacement by time. అంతే కదా? Yes. Okay. Displacement, hey, half rotation ante initially the ball was here, completed half rotation and came here kada. Yes. What is the displacement, sir? This much is the displacement. Hey, I am not talking about distance, right? It is talking about average velocity. Choose not average speed. Speed unte you will take distance ante pi r. But it is talking about velocity. So for velocity, you will have to take this radius r. Radius r ante total displacement is 2r. So velocity v bar is equals to displacement is 2r divided by time. Time cheppandi ra. What is time, Ray? Hey, speed is v. Time is 2 pi by omega. Total time, Ray. Total time. Chuskondi. Or leda, you write this much distance, Ray. Distance. You have speed, Ray. You have speed. Then you have to talk about distance. Sir, distance is equals to speed into time. Ante kada. Cheppo. Distance how much, Ray? Total distance. Distance ante idi total distance. Half of the circumference kada. Pi r. 2 pi r total circumference. Pi r half circumference. So pi r is equals to v into time. Ante you send there, Ray. You send it there. Cheppo. So sir, time is equals to pi into r by v. You substitute the same time over here. Sir, speed average velocity is displacement by time. Displacement is 2r divided by, sir, pi r by v. Ante kada. This v goes up. R gone. So sir, it is 2v divided by pi. Then average speed. Not speed, velocity actually. Okay. Good. Chalo. I'll give you 2 minutes time, Ra. You solve this question and tell me the answer. Very easy question actually. Yeah, Gonat, it is only possible by doing extra calculations only. Not pi r by v, mystery. How pi r by v? Yeah, time. Yes. Time is pi r by v. Good. Very good. Chuddam, I don't know the answer, okay? I don't know the answer actually. I have to solve it. Getting any answers, Ra? Are you coming to any results or conclusions? Why is the chat box so empty? Hmm. Ugh. Let us see. Let us see. Okay, so if all are getting the same answer, and it must be right. Must be right. Vidamma. Radii of circular path of two particles of same mass are in the ratio 6:8 ra. Ante R1 by R2 ki value by 8. Okay. What will be the velocities ratio if they have constant centripetal force? Ante centripetal forces are same ra. Ante F1 is equals to F2. Centripetal force ki formula cheppura. Sir, m into v square by r for the first particle should be equals to m into v square by r second particle. Tegada cheppandi same mass and same mass ante m re m is same gone. v1 r1 v2 r2 ante kada. So sir, v1 square divided by r1 is equals to v2 square divided by r2. Okay, the ratios are in this way. You can swap the ratios. Ela swap chestaru sir? Take numerator ratio, denominator ratio together. Ante v1 square divided by v2 square is equals to r1 divided by r2. Kada. Okay. So r1 by r2 ante enti ra? 6 by 8. Ante 2 3s are 4, 2 3s are 6. Take the square root now. Sir, v1 by v2 is equals to root of 3 by 4 ante root 3 divided by root of 4 re 2. Okay. Good. Option A. Next. Not next actually. Questions are over. Yes. 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 Root 3 by 2 is the right answer. Okay. Okay. Right. So I'll give you a homework question. Okay. Should I give you a homework question? Cheppandi okasari. Yeah, no problem, doc. All right, it's all. Okay. Take it as a homework. Okay, do it. Okay, so inverse అంటే ఏంటి? Hi Vaishu, hi. Okay, Ritik, let us see. That is a possible combination actually, but let's see if it is there or not there. Good. By the way, very good approach actually. Okay, very good. Okay, so if you don't have any problem, can you finish the session? Should I explain? Should I explain? Okay, let us try to explain the question. Okay, right? It's only inverse relationship, right? So let us see. Sir, centripetal force F1 it is equals to F2 it is equals to F3 kada. Values cheppandi ra. Sir, M1 V1 square by R1 should be equals to M2 V2 square by R2 should be equals to M3 V3 square by R3 ante kada. Yes. I think it will be done in 5 minutes, okay? In only 5 minutes. 5 minutes it will be complete. Yeah, ratios only. So that means take the ratio of numerator, take the ratio of denominator. Ante enti ra? Sir, M1 V1 square by M2 V2 square by M3 V3 square should be equals to R1 by R2 by R3. You can always take it, okay? Okay? Always you can take it. So that means substitute చేసుకోండి m1 v1 square అంటే m1 is m and v1 is 4v. So sir, m into 4v whole square divided by, sir, second mass 2m 2v. So it is 2m divided by 2v whole square divided by, sir, third mass third velocity. So sir, it is 4m into v whole square should be equals to r1 by r2 by r3. m gone, v square gone. చూసుకోండి 4 square is 16 రే. 16 divided by 4 into 2 8 divided by 4 is equals to r1 by r2 by r3. అంటే we say r1 by r2 by r3 is equals to, 4 ones are 4, 4 twos are 8, 4 fours are 16, 4 is to 2 is to 1. Right answer. Okay, Ritik, very good. Yes. Okay, good. All of you. Okay. Done. Same force ante same formula. Go not. mv square by r, mv square by r, mv square by r, same. So you remember there is this mathematical operation. If you have this ratio and proportion, if you have a by b is equals to c by d, we can take the ratio of numerators also. So that means a by c is also equals to b by d. This is numerators everywhere and this is the denominators everywhere. Okay, so that means if you have a1 by b1 is equals to a2 by b2 is equals to a3 by b3 is equals to a4 by b4 and so on so forth. So what you can take the ratio of all the numerators. Ante a1 by a2 by a3 by a4 by a5 should be equals to b1 by b2 by b3 by b4 by b5 and so on so forth. Yeah. Okay. So you can always take the numerators together, you can always take the denominators together. If you have the ratio something like this, for example, I'll tell you, sir, 1 by 2 by 3 is equals to, not like this, right? Okay. Sir, 1 by 2 is equals to 4 by 8 is equals to 10 by 20. Ante kada? Say 1 by 4 by 10 is equals to 2 by 8 by 20. How, right? How? Divide by 2. 2 ones are 2, 2 fours are 10, 2 tens are 20. 1 4 10, 1 4 10. Same kada? You can take numerator in the same side and it takes denominator in the same side. Ante kada? Yes. So, Gona, that's more than sufficient actually. Tomorrow, Ripu will try to see some more questions if possible. And if it's not possible, okay, I'll be starting the new chapter. Now, what chapter to start? Cheppandi andariki. So, I have two different options. If you are a dropper, then we can go with the two options that I have is Leda. So in the comment section of the video, you tell it, okay? In the comment section of the video, the time is already over, right? In the comment section of this video, you tell me which video to start. NLM and NLM or current electricity, okay? Current electricity. Okay. Okay, so let us see. Fine, we'll end this session, okay? We'll try to finish this as soon as. Okay. Yeah, chalo. If you don't have any problem, then we can wind up with this session, right? Thank you so much. Darkan, thank you so much. Donut, thank you so much. Thank you so much. Bye, bye, bye. Arey, what's your name, Ray? Duppala. Raghuram. It's over, right? It's over. The time is over. So, okay, good. Good. Let us see. Let us see. Bye, bye, bye. Bye, all of you. Bye. Okay. Bye, all of you. Bye, bye, bye. Bye, bye, all of you. Bye.